In this video, we're going to talk about the maximum and the minimum values of a quadratic function. Now, recall that the way a parabola opens, that depends on the sign of a, the coefficient of x squared, right? So, if a is positive, then the graph opens up like this. If a is negative, then the graph opens down like this, right? So this means if a is positive, because the graph opens up, this vertex is going to be the lowest point on the graph. And if a is negative, then the graph opens down, so the vertex is going to be the highest point on the graph, okay? So what does that have to do with the maximum and minimum values? Okay, here I've got two pictures. I'll go one by one. So the first one, the graph opens up, and as a consequence, the vertex is the lowest point. Say this vertex is, I don't know, 5, 2, okay? The y value, remember, is the function value, right? So because 5, 2 is the lowest point on the graph, the y value of this function is never going to be less than 2, okay? So all the y values are either going to be equal to 2, or they could be higher than that, right? So for example, this point might be 6, 4, for example. See, the y value is bigger than the y value at the vertex 2, right? So we say that the minimum value of this function is equal to 2. All other function values are going to be bigger than 2, okay? So that's the minimum value. On the second picture here, I've got a parabola that is open down, right? Let's say this one, the vertex is 4, 3. Again, this being the highest point, the y value here, the 3, is going to be the maximum value of the function. So the maximum value of this function is going to be equal to 3. It's always going to be the y value of the vertex. Now sometimes you will be asked, where is the minimum located, or where is the maximum located, right? So to provide the location, you specify the x value. So for example, we say that the minimum is located at x equals 5, right? So that's the x value of the vertex. Or in this case, we say the maximum is located at x equals 4. Again, we specify the x value of the vertex. But the actual minimum value of the function itself, or the maximum value of the function itself, is always going to be the y values of the vertex. Okay? Alright, now that we know what the minimum and maximum values are, let's take a look at a couple of examples where we actually find those, okay? So, this first example, we're given a function f of x equals 3 times x minus 40 squared plus 2. And then we want to do two things. First, decide whether this function is going to have a maximum or minimum value. And then once we decide about that, we'll tell what the maximum or the minimum value of the function is. Now, notice that this function is written in vertex form, right? So if you were to compare this with the vertex form a times x minus 8 squared plus k, you'll see that the vertex is h comma k, right? So h is 4, and then the k is 2. So we got the vertex 4 comma 2. Now we got to decide which way this parabola opens, right? So for that, we need to look at the sign of A. So here, A is 3, which is positive, right? So if the A value is positive, the graph opens up sort of like this, right? So here's going to be our vertex 4, 2. So this vertex is going to be the lowest point. So that means this function is going to have a minimum value, right? And then the minimum value is going to be the y value of the vertex. So the minimum value is going to be 2, okay? Let's take a look at another example. Here we got a function that's written in the standard form, ax squared plus bx plus c. We can't tell what the vertex is right away because it's not in the vertex form, okay? So if the function is given like this, we gotta first find the vertex, and then we can tell the maximum and minimum value. Let's first take a look at the sign of a, the number next to x squared, right? So a is -2, which is of course a negative value, right? It's negative. So that means g of x has a maximum value. Why? Well, because a is negative, the graph is going to open down, so the vertex is going to be the maximum point in there, okay? So we know what this g of x is going to have. It's going to have a maximum value. Now, if we could find the y value of the vertex, that would be the maximum value of the function, okay? Now, there's a formula to do that. So we'll start with the x value. The x value of the vertex is going to be given by x equals -b over 2a. Okay, so we just have to plug in the value of a and b in here. So here we got the a value, -2, and then the b is 4, right? So let's plug that in here. So I got a negative in front. B is a 4 divided by 2a. So 2 times our a is -2. All right. So this is negative from the front. 4 over 2 times -2 is -4. Now this is a negative of 4 divided by -4. Well, 4 divided by -4 is -1, and negative of that is +1. So that's going to be the x value of the vertex, okay? But we need the y value. That's what the maximum value is going to be. So to find the y value, you got to plug in this x value that we just got, 1, into the function. So in other words, we need to find what g of 1 is. So let's plug in 1 for x here. So -2. Now we got x squared. So x is 1, so it's squared. Plus 4x, so 4 times 1, plus a 3. 1 squared is 1 times a -2 is -2. Plus 4 times 1 is 4, plus a 3. Now, -2 plus 4 is +2, and then plus 3 is 5, right? So that is going to be the y value of the vertex. So let's write down what the vertex is. So the vertex is 1, 5. And we already decided that this function is going to have a maximum value. And let's just write the maximum value of the function then. The maximum value is therefore going to be equal to the y value of the vertex, which is 5. Okay. So that's how you find the maximum or minimum value of a function if it is given in the standard form. I hope you enjoyed this video. Thanks for watching.